Hello and welcome back to another VMK in the game development series. In this VMK we're continuing working with our geometry cylinder, and this time we're adding texture coordinates to the cylinder so that we can texture map it. Let's go into PaintShop Pro to see how we can accomplish this. Okay, I've drawn a 5-sided cylinder here on the screen, and I'll show you how we can go about to texture map this guy. Again, the origin of this guy is going to be located in the center of the bottom face, and the distance from the center off to the edge here, this is going to be the radius of the cylinder, and this coordinate in terms of vertices is going to be V0. But I'm not going to be talking about vertices at all in this video, or at least minimally. Instead, we're going to be talking about the texture coordinates. Now, for the texture coordinates, this texture coordinate is going to be T0. And what we're going to do is we're going to wrap our texture around counterclockwise around the face of the column section. So this is going to be T0. This one here is going to be T1. This one here is going to be T2. This one's T3. This one's T4. And now notice we need another coordinate here at the same location where T0 is, and this one's going to be T5. I'll talk about this in a second, why we need two texture coordinates at one location. We didn't need this for vertices, but we do need it for texture coordinates. Then we go up to the top. We have T6, T7, T8, T9, T10, and then again we have a double texture coordinate here. This one's T11. Now, in addition to that, we also need texture coordinates from the top and for the bottom faces. These texture coordinates that I've just shown here, excuse me, there are 12 of them. However, they only define how to texture map the sides of the cylinder. They don't tell me how to texture map the top and bottom. So we need to create an additional set of texture coordinates for these top and bottom faces. However, we're going to cheat a little bit because we want to minimize the amount of data that we store inside of a class. And because both the top and the bottom faces are symmetrical, we can use the texture coordinates for one of them also for the second one. So we only need to save one set. So because of that, I'm going to go under here and I'm just going to pick a different green color, and I'll label this as T12, T13, T14, T15, and T16. Now we don't need another double here for this top one, and you'll see why whenever we go and talk about the actual code implementation. The texture coordinates for the bottom face are going to use the texture coordinates that I've labeled here up above, so I'm going to relabel them down below here as well. T12, T13, T14, T15, and T16. So as you can see, with a cylinder that has the number of sides equal to 5, we end up needing all these texture coordinates. And there's a total of, let's see, 16, 17 texture coordinates. Now, how do we get the 17 from this number of sides? Well, what we do is we take the number of sides plus 1, because we're going to count how many we do in the cylindrical part. Remember, we started at 0, we went all the way around to the end, and then we added 1. So we have number of sides plus 1, but we need 2 of those because we also have the top section here. So multiply that by 2. But then in addition to that, we also need the texture coordinates for the top face, which we duplicate for the bottom face, but we need to define how many we need for that as well. So in addition to that, we also need another number of sides equivalent of texture coordinates. So when we plug in 5 here, we get 5 plus 1 is 6. 6 times 2 is 12. 12 plus another 5 gives us that 17. So that's the formula we're going to use to determine how many texture coordinates we're going to need for a general shaped cylinder. Now, when we have our texture coordinates in this fashion, how is it that these texture coordinates are going to be represented in a file? Well, I can show you this by going to the following image. What we're going to do is we're going to take any texture file, and again, remember, all texture files are going to assume that they're going to be square, and we're going to define them as follows. Again, remember, always at the bottom we have 0, 0, and located at the top right-hand corner, the texture coordinate is always 1, 1. Now, the cylindrical part of our cylinder, so the column part of our cylinder, is going to be texture mapped using the bottom half of the image. So we're only going to go up to the halfway point here, so this is going to be 0, 0.5. And we're going to go all the way over to the end here, so this is going to be 1, 0.5. And this other coordinate is going to be 1 and 0. So this bottom section represents the column section of the cylinder that we're going to texture map. And I'll just label this as side. Now, the top section is going to be texture map using this part of the image. So we're going to locate the very center of this square here, and the coordinate for that is going to be 0.25 and 0.75. And then using this coordinate, we can use a unit circle. Well, I guess I shouldn't say unit circle, but we're going to use a circle that's centered about that point, and that's a pretty bad drawing for a circle. Let me try that again. We're going to go like this. That's not much better, but you get the idea. So all the texture coordinates are going to get pulled off of this circle here for however many points we have on our cylinder. Same thing goes for the bottom face. The bottom face is going to come from the part of the image that's over here, and again we're going to have a circle inscribed in here, and this center point here is going to be 0.75 comma 0.75. Oh, that should be a 7. And anytime we need texture values, we're just going to pull them off of the image here that's going to be located in the top right hand corner. So I'm going to label this here as the top, and this is going to be labeled as bottom. Okay, so that's the idea. Now let's go see how we can implement this. First thing we need to do is create a member variable that will contain the texture coordinates. So inside the geometry cylinder.h file, we're going to add the following: vertex 2 and m_t. Okay, and then let's go into the CPP file and actually implement these texture coordinates. In the constructor, we're going to initialize all the texture coordinates to null, since we don't have any memory allocated yet. And then we're going to call m_t equals new. Actually, I should just do the following. New vertex 2, and then the number of texture coordinates we need is I number of sides plus 1 times 2 plus I number of sides. And again, that comes from this over here, where we're counting how many texture coordinates we need for a given cylinder of a certain number of sides. Now, if the memory is allocated correctly, m_t, then we can go down here. If it's not allocated correctly, then we can just call safe delete. And we should also do this inside the destructor so we don't have a memory leak. Alright, now what are we going to do next? If you compare the number of texture coordinates here with the number of vertices we have, you'll notice we have one extra set as we go counterclockwise in this column. So to be able to make use of this for loop down here to do texture coordinates, we have to manually add one extra set of texture coordinates. So we're going to do that right after we go inside this if statement and before we go inside the for loop. So we're going to assign textures along the seam of the column. So we're going to set the texture coordinate for 0 equal to vertex 0, 0. So this is the very first one. This is basically this guy here. And we're also going to do this one here, which is T6 for us. And from then on, we're going to go and calculate all the texture coordinates for everything else at the same time that we're calculating all the vertex coordinates for the specific cylinder that we want to create. So the first one, T0, is 0, 0, and the one up above it, the I number of sides plus 1 value, is going to be 0 and 0.5. And then once again, let me just go back to this image here. So we're defining this texture coordinate and this texture coordinate here, 0 and 0.5. Alright, then we're inside of the for loop, and inside here we calculate the x value, the z value, and save it as the vertex coordinates for the specific cylinder. While we're in here, we can also do some work to calculate all the texture coordinates that are remaining for the column part of the cylinder. And that's what I show here. So we're going to step from 1 plus I, since we're going from I here equals 0 all the way to I number of sides. So we're adding 1 here. And the texture coordinate for this guy is going to be equal to I plus 1 divided by I number of sides for the x value and 0 for the y value. For the other guy up above, we're going to take that same ratio, but then the y value is 0.5. So in other words, what we're doing is we're taking this section of the image and breaking it down into strips. And for us, we had a 5-sided cylinder, so we break this down into 5 sections. 1, 2, 3, well, I guess that's not very accurate here. Let's see. 1, 2, 3, 4, and 5. So we need to have the texture coordinates for the following sections of the image. We need this coordinate here, which is going to be some value, comma, 0. This one here is going to be some value, comma, 0, and so on, all the way down to the very last one. And this first value is going to be the total length, which we know is 1. So we can just take 1 divided by and however many sections we have. So inside of our code, the way we've done that is we take 1 divided by number of sides, so that gives us the number that we have to move over, and then we multiply by I plus 1 to give us the actual coordinate along horizontally here. Alright, then we need to assign the texture coordinates for the top and bottom sides of the cylinder at the same time. Well, we're only saving the top, but we're going to reuse the same texture coordinates for the bottom, and I'll show you how we can do that with a little bit of a trick down below. We do something very similar to what we did here for the vertex values. However, these values here, fx val and fz val, are used for the texture coordinates. We know that the texture that's located up here is going to have a radius of 0.25, because if we split this whole square up the way we've done here, this section is going to be half of the image, so this section is going to be 0.5, but this circle on the inside is going to be centered about that section, so the radius of this is 0.25. So going back here, we have 0.25. Now we want to get the x value, so we use cos, and then we use this ratio here to get the appropriate section of the circle that we need for the texture coordinate. So whatever this value returns, we then add 0.25 to it, because we know that we want to get the values offset by 0.25. So we want a circle with the center of 0.25 in the x located here. And then we do something similar for the z because we want 0.75 to be the vertical displacement. So here you see down below for the z value, we're calculating 0.25 for the radius times sine times that ratio, and then we're adding 0.75. Both of these values, once we have them, we can then create a vertex 2 variable out of these two values, and the z value actually becomes a y value, but I'm just reusing variables, so that's why we're choosing here fz value, and we're saving that inside the following texture coordinate. This math here basically tells us, let's go back into here and back into here. It tells us, okay, which of these texture coordinates do we need to fill in? Well, we're filling in T12, T13, T14, T15, and T16. So go through the math if you really want to see how this is working, and you'll notice that this guy here is giving me the texture coordinates for the top face, and this here is giving me the texture coordinates for the column section of the cylinder. Alright, so now that we have our texture coordinates defined, we need to go down inside of the render function, render OpenGL, and fill in what we do here whenever we do use texture coordinates. Basically, everything that you see here is exactly the same that we did below, with the only addition being that we now define the texture coordinates. So we've seen all this before. We have GL begin, GL quads. If we're not smoothing, we then use the face normals. And then we have an if statement here, which defines the first section of the column vertices. And then down below here, we have the second section of the column vertices. But for each of these now, you'll notice that I added the texture coordinates. So here we're using texture coordinate m underscore I number of sides. That's equivalent to the 0 vertex. And for this guy, m underscore I number of sides, we need to use 2 times m underscore I number of sides plus 1. And for the ones that are not on the scene, we use the following texture coordinates, v plus 1 and v plus 2 plus m underscore I number of sides. For these ones down here, we're using v plus I number of sides plus 1, and this one is using v down here. And finally, we have the top cap and the bottom cap. Now remember, we only save the texture coordinates for the top cap. So here we're using the texture coordinate 2 times mi number of sides plus 2 for these vertices. But for the bottom cap, we're using 3 times I number of sides plus 1 minus v. And what this really is doing is it's exactly the same as this, but the texture coordinates are in the reverse order. And remember, this for loop is in the reverse order of this for loop. So we can't use the texture coordinates that we had up above. Well, we actually could, but if you do that, then you'll notice that your image is actually the mirror image of what it is in the file. So to fix that, I had to flip the texture coordinates to be in the opposite order so that they work for the bottom face. So that's why we have a little bit different kind of math here to define which texture coordinate we're using for the bottom face. But beyond that, we're using the exact same values that we needed to use before. Oh, and one other thing I have to point here is the texture coordinates, you have to offset them by a half. And remember, back here in PaintShop Pro, we've defined and saved the texture coordinates for this circle here. However, we want to get the part of the image that's located over here. The texture coordinates are going to be located in the same spots in this unit circle as they are over here, but they're all going to be shifted over by exactly half a unit to the right. You notice this circle is centered at 0.25, but this circle is centered at 0.75. So it's everything's shifted by 0.5. So because of that, inside here, we have a different index, but then we're also adding 0.25 to the end here. And by doing that, we're extracting the part of the image that's located at the top right, rather than extracting the part of the image that's located at the top left. So that's the only difference here between the top cap and the bottom cap. It's a little bit of a smart way of reusing texture coordinates without actually having to save more texture coordinates for your cylinder. And everything else down below here we don't need to change. It's a lot of math, a lot of manipulation of these indices, but once you understand of what's trying to happen here, it's not too difficult to program. So let's save that and compile this, make sure it's okay. Okay, and now we can go inside of our scene and make use of this texture. Actually, what I've done is, before I go and talk about that, let me show you the texture I'm going to be using. Just close this guy off, close this guy off. I went online and I went under Google Images, and let me show you that. And I think I typed in something like texture, barrel texture, or something like that. And if you click on images, do a search, you get all these images for barrel textures. And here's one actually that could be useful. Someone already went ahead and created a texture image that would be usable in our game engine. Notice here that their side section, or the column section, is located at the top of the image, and their top and bottom of the cylinder is located at the bottom of the image. So if we wanted to use this image, we would have to basically rotate it 180 degrees, or flip this section to the bottom and this section to the top. But basically what I did is I just did a search and I found, oh, here's someone who created this following texture, which I didn't have to manipulate at all because already it was in the right orientation. This bottom section is for the side of the column, this is the top, and this is the bottom image. So I saved this as a TGA, and I put it inside of the build, debug, resources, textures folder. So here it is, barrel.tga. Having it there, we can now go into our code and load it into our game. So in here, let's go and create a new texture, quality 4, p-handler, mapping turned on, quality 4, solid. This image is solid, so we don't need to use that last parameter. And we're going to load the texture. It was called barrel.tga. And I'm going to create a unsigned integer to reference this guy. And we'll call him unsigned integer, let's say text barrel. Like so. Now we can go down inside of our code for the cylinders, and we can just assign text barrel, and we'll also apply it to this one down here. So both our smooth cylinder and our faceted cylinder are going to be textured now. But the other thing I want to change here is the size of our cylinders. Because right now they're kind of short because I squashed them. So let's see here. 20-sided cylinder, radius of 0.25, height of, let's make it 0.5, and I'll change this back down to 10. And let's save this, build it, and take a look. And there we go. We have the cylinder on the right-hand side, which has the smooth shading, and the cylinder on the left-hand side, which has the faceted shading. And you can now notice that once we apply a texture, it's becoming more and more difficult to see that the cylinder on the right-hand side is actually faceted. The texture on the left-hand side, or well, I guess now it's on the right-hand side, it is faceted, and it's easy to see because the normals are per face, not per edge. Whereas the one on the right-hand side now, the normals are defined for us on the edges, so it looks more smooth to the human eye. Alright, so that's pretty good now. You should be able to go through, make manipulations as you need. If you're creating tires, you can go ahead and inside your texture specify here in the bottom section to be the tread of the tire, and then this section here would be like the rims of the tire themselves. If you're using barrels, you do something like this, and you get the idea. It's pretty simple. If you have any questions about the cylinders in the game engine, feel free to post them at the website. Once I get this video posted, you'll find in the community section there'll be a new link where you can talk about the cylinder section, and under there, if you have any questions, feel free to ask. You'll notice that there'll be a game dev VMK 29. So in there, just post any questions you have about cylinders. And if you have any confusions with some of the trig math, I also recommend you go take a look at the mathematics VMKs, because under the math ones, I'll add a new math video here that talks about the unit circle a little bit more to hopefully help anyone out that is getting confused with the trig math.